are looking at the effect of an increasing temperature on this reaction after it's reached equilibrium. What will happen to the concentration of the reagents? Now, to establish the original equilibrium, the rate of the reaction will decrease. Am I right? To reach equilibrium somewhere. That is for hydrogen. For nitrogen, the rate of the reaction will decrease in tandem. Am I right? Okay. So this is how the concentration of the nitrogen will change. At which point is equilibrium established?
That point.
Here where they flatten out, equilibrium is established. Okay. What happens to the rate of the reverse reaction?
It will increase.
It will increase. And we use a broken line. Now, the mole ratio is 3 to 1 to 2. So
it will be more than the nitrogen, but less than the hydrogen.
Yes. So this is the rate of the change in concentration of ammonia. Are you happy with that?
Yes.
So at T1, equilibrium was reached, and at T2 we change the equilibrium condition. Okay? What happens? We increase the temperature. What is going to happen to the concentration of the hydrogen and the concentration of the nitrogen? It would increase. Why would it increase? It's favoring the reverse reaction. But this increase, listen carefully, this increase isn't a sudden increase. It's going to be a gradual increase, because we're not adding hydrogen or nitrogen, we're forming hydrogen and nitrogen with an increase in temperature. So the reaction will, for hydrogen, it will be a gradual increase until equilibrium is established.
That's when heat is added. That's when heat is added.
When you are increasing the temperature, when you add heat, yes. And so will the nitrogen concentration. It will gradually increase to reach a new equilibrium. And what will happen to the ammonia concentration? It will gradually decrease to reach a new equilibrium.
What did we do?
We increase the temperature.
But what's the concentration of that? Because it favors the reverse reaction, and the reverse reaction decreases the amount of ammonia. Oh. Come on, buddy.
You need to think about
How did you decide that we favored the reverse reaction?
That was actually my question. My question was, how do you know whether it's favoring the reverse or the forward reaction? If you increase temperature, all of them will increase.
You look at
the rate of them all will increase, but you need to look at what the change in enthalpy is for the forward reaction.
What if they don't do it?
So if it's exothermic,
They have to say, they have to indicate.
so it is
Or in some way or another, they have to indicate it. Or they would say an increase in temperature will increase the concentration of the hydrogen and the nitrogen. And then ask you, what is the sign of the change in enthalpy before the forward reaction. Is meaning that you need to deduce from the information they give us what the forward reaction will be. Will it be exothermic or endothermic?
So if it's exothermic, then that means that the forward reaction is favored.
By what?
If it's exothermic, does that mean that the forward reaction is favored?
In this reaction, yes.
I don't know by what.
By what will the forward reaction be favored? An increase in temperature.
If it's exothermic.
The forward reaction is exothermic.
Yes.
You want to favor the forward reaction by an increase in temperature. Because
she's asking.
You're confusing everybody now.
She wants
I'm
to
not
know.
confusing anybody. I'm trying to work from her statement. She says an increase in temperature will favor this reaction, the exothermic reaction. I'm trying to make her think about what she said. The forward reaction is what? Exothermic.
Yes.
Exothermic means it gives off a lot of heat.
Yes.
Yes, so it heats up things.
Yes.
Now you are heating it up from the outside. Well, heating it up from the outside favor the heating up reaction, the one that gives off heat. You putting more heat in, this thing is giving off heat. Is that opposing the exothermic reaction?
Ma'am, are you saying that if, because you're heating it up?
I'm not saying, I'm asking.
Ma'am,
Answers, you know.
ma'am, so, ma'am, just to know this is what you're asking. Are you asking that?
You told me, the way I heard you, is you told me that increasing the temperature will favor the exothermic
I was
reaction.
asking.
You were asking me.
I was asking if that's always the case.
It's never the case, because Le Chatelier applies, Le Chatelier's principle applies to reversible reactions. So if a reversible reaction is in equilibrium and you change the temperature by increasing the temperature, you will favor the reaction that will drop that temperature, which is?
The other one. The reverse.
No, you don't know whether it's the reverse yet. It is the reverse here, but what do we call the reverse reaction? Endothermic. An increase in temperature, meaning you're heating it up, will favor the reaction that opposes that increase in temperature. So the one that cools down everything. Which one cools down everything? The endothermic. Endo means it takes in energy. Takes in. So it cools. Yes, taking in the energy cools down. Yes.
It's coming.
You have to look at this.
If the forward reaction was endothermic, right?
No, we're not working with that.
No, I'm just
Are we ever going to work on
I'm
that?
making a scenario. I'm just making a scenario, man.
Then you have to swap around the equation. Then you have to write this equation from the point of NH3 going to N2 and 3H2. This is your endothermic reaction. This is the reaction where an increase in temperature will favor. No!
The forward reaction.
Oh no, AJ, I'm actually being so serious.
The increase in temperature will always favor the endothermic reaction. Always. In this way, we have written this equation. The forward reaction is the endothermic reaction. So the increase in temperature will always favor the endothermic reaction.
Regardless of, like, it's just standard.
In this example, it is the forward reaction. So if we look at the forward reaction decreasing in the forward reaction being favored, the forward reaction here only considers decomposition of ammonia. So there we have to look at this as the equilibrium situation. Okay, wait, let me finish talking now. You will start with no hydrogen and you will start with no nitrogen initially. So the concentration of the hydrogen and the concentration of the nitrogen will increase now. I'm going to do it in different pens. So the hydrogen concentration will increase to there, and the nitrogen concentration will increase to somewhere in between. Am I right? No, it's lowest. It's the lowest. Yes. There.
That's the hydrogen.
No, this is the concentration of the nitrogen. That is the concentration of the ammonia. And the last one, the top graph, is the concentration of the hydrogen. Okay? Now, we change the temperature. At this point in time, we change the temperature. We are going to increase the temperature. Which reaction is favored? The endothermic reaction, and the way we wrote the reaction equation down, it is the forward reaction. So what is going to happen to the concentration of the hydrogen? What's happening to the concentration of the hydrogen? It will gradually increase. What will happen to the concentration of the nitrogen? It will gradually increase to re-establish equilibrium. What will happen to the ammonia's concentration? It will gradually, decrease.
So, ma'am,
To form a new equilibrium. Yes.
if more energy is put into the system, it will favor
The reaction
The
that
reaction
will
that's-
use up the energy.
and if energy is taken out, it will favor the one that gives off energy.
Yes, that's what the reversible reaction is about. If it's at equilibrium and you do something to disturb the equilibrium,
Or try
the
to-
reaction will try and work against that disturbance. The setting.
I was just going to ask, can we treat the system and say endothermic instead of, and not say whether it's forward or reverse?
Now, in the end, you have to say what happens to the concentrations of the thing. So here, you start with referring to endothermic and then say it favors the forward reaction. Because sometimes the endothermic reaction is the forward reaction, and sometimes the endothermic reaction is the reverse reaction.
Finally coming.
If the reaction is written down like this, the forward reaction is exothermic. Then an increase in temperature will favor the endothermic reaction, which is the reverse reaction. Equilibrium will shift towards the left in this case, and in the second slide, the equilibrium shifts to the right.
I get confused how the shifts.
the reaction that is favored, that is where the shift will take place in. It's another way of saying more of this will form. So here, saying the equilibrium shifts to the left means that the concentration of the hydrogen and the concentration of the nitrogen will increase. Because an increase in temperature favors the endothermic reaction, which is with the two H's there, which is the reverse reaction.
Ma'am?
Yes.
When the concentration of hydrogen and nitrogen increase, does that mean that the moles increase or the volume decreases?
It really depends on the situation. When we change temperature, we don't change volume, so the moles will change.
So the moles will be higher.
Yeah.
Because you need a higher numerator.
Yeah. You won't increase the temperature of a reaction mixture by changing the volume. You'll increase the temperature by heating up the system, or you'll decrease the temperature by cooling down the system.
Now, I have a real question. You see, ma'am, how we take the reactants and then form the products, and that's exothermic. Is endothermic taking the products back to reactants?
Yes.
Lovely. You see, now we understand.
Okay. So you need to look at the way the reaction is written to identify which reaction is exothermic, which reaction is endothermic.
So now with regards to the shift in equilibrium, in this instance, where which side?
Here the equilibrium will shift to the right because it makes more nitrogen and hydrogen. You see the hydrogen concentration goes up and the nitrogen concentration goes up. The ammonia concentration goes down.
Okay. So the ones that are increasing, that's the direction in which
Yes. Hugo? I find it more comfortable to do the basic explanation with one reaction and then to do more examples. So I want to first do the pressure change and then a catalyst, and then we can look at different examples. The basic principle stays the same. We'll do it now.
just a second.
So which one do you want to do? This one? Because this is the industrial process. They take hydrogen, they mix it with nitrogen, and they produce ammonia.
Yes.
This is the industrial process.
It's just over here to give us like zinc and it's the antimony.
Expose yourself to the question papers and you'll see what you will be getting. So for this, the forward reaction is exothermic, it gives off energy.
Can you give us a
So
chance
let's
to-
cool the system down, we decrease the temperature.
Can we try to do it ourselves first?
Yes?
Join the graph for this.
So decreasing temperature will favor the exothermic reaction because exothermic reaction gives off heat, so it opposes the effect of decreasing the temperature. In the way the reaction is written, it is the forward reaction that will be favored. So the equilibrium will shift to the right, meaning that the concentration of ammonia will increase, the concentration of the hydrogen and the nitrogen will decrease, and then at lower temperature everything will slow down. So less particles will have enough energy to react. The rate is slower. Now go and draw the graphs. Okay. So the concentration graph, I'm just going to draw them at equilibrium. So the hydrogen's concentration is constant. The nitrogen's concentration is constant and the ammonia's concentration is constant somewhere. They are at equilibrium, so they're constant. And I'm deliberately drawing the graphs like this and pointing out that it's concentration graphs because the concentrations of the reagent stays constant, but they're not equal. That's important to realize. So, green is for ammonia. So that is the reverse reaction decomposing. Am I right?
Yes.
It was the reverse. No, wait a moment. The forward reaction is the hydrogen and the nitrogen's reaction. And we are favoring the forward reaction. No? Yes, we're pushing the reaction forward. So, no, wait a moment. The hydrogen will be used up gradually. The nitrogen will be used up gradually. Am I right?
Yes.
And the ammonia will be formed. More ammonia will be formed gradually. So this one is for NH3. That one is for H2. And this one is for N2.
I do understand the concentration graph. Like I understand the 100%, but the red graph, I don't understand it.
When you decrease temperature, everything will be slower. Collision theory, everything will be slower. So both reactions drop. The rate of the reaction drop. The reaction will take place slower.
Oh, and then ma'am, you see the forward, that dotted line?
Here,
That's the forward reaction.
that's for the reverse reaction.
So it has an instant sharp shoot that goes down, right?
Yes, because you're favoring the forward reaction. This one drops faster. It drops more.
So that, okay. And then, but ma'am, in our words, we say that it decreases.
Yes,
Wouldn't that be but they're increasing again. Wouldn't that be the ammonia?
but a new equilibrium must be established, so the rate of the reverse reaction will speed up.
Ma'am, isn't the dotted line the forward reaction?
No, this is the forward reaction.
Ma'am? Will the exothermic reaction always change the most?
No, the endothermic reaction changes.
Will the endothermic always change the most?
With a change in temperature.
Yes.
Yes.
Ma'am, so with rates, we only look at
The endothermic reaction will always
Yes.
change the most in the
Each amount.
with a change in
Yes.
temperature.
You have to go. So just to confirm, with a decreasing temperature, both forward and reverse reactions will slow down. The endothermic reaction slows down most, and that is the reverse reaction. Slows down most. But as ammonia forms, it will speed up the reverse reaction. As more ammonia form, more. This will become more because the forward reaction is favored by the decrease in temperature. The reverse reaction will speed up, and that is what is indicated by that increase in rate of reaction. And as the reverse reaction speeds up, the forward reaction will slow down to reach the new equilibrium. Yes.
Does this go back to, you see, when we started this topic, you see how if the thing forms, then the other breaks, and then that's what's basically happening.
That's literally the topic.
Okay. Can we go to a change in pressure?
The topic is equilibrium.
So although it slows down most, it must speed up. It must speed up to reach equilibrium. Okay. had changes in pressure. Changes in pressure could be brought about by an increase in concentration of reactants or a decrease in concentration of reactants, but usually it's brought about by a change in volume. So, change in volume will change the pressure on gases. So we are only we need to check how many moles of gas is on the reactant side, compare it to the number of moles gas on the product side. So the comparison is not difficult to see. How many moles of gas is there on the reactant side?
2,
3.
3,
Reactants 3.
There are 4 moles of gas here compared to 2 moles there.
So it's 2 to 3.
Okay.
How many graphs?
Okay. So let's increase pressure. Please look and learn. I'll give you time to write it just now. Le Chatelier says that whatever you do, the reaction will react to oppose the change. So if you increase the pressure, you're making it more difficult for 4 moles of gas to exist there. It will be easier to have 2 moles gas existing.
Yes.
Okay? So squash the gases, make the volume smaller.
So it's much more.
Then you will increase the pressure in that way, but you'll favor the reaction that will decrease the pressure.
So the forward reaction.
The forward reaction in this case.
Yes, okay.
2 moles gas will exert less pressure than 4 moles gas.
Yes.
Because
Forward
this
produces
way.
2 moles.
This way.
Okay, yeah,
This way.
repeat what you said.
Okay? So can I say it again?
Yes.
The 4 moles gas exerts a bigger pressure than 2 moles gas. Okay? So if you increase the pressure, you will favor the reaction that will make less moles gas. Because less moles gas will exert less pressure. But the reverse reaction makes 4 moles gas for every 2 mole there. So in this case, when you increase the pressure, the reaction that will
Decrease volume.
no, we can decrease the volume, increase the pressure by decreasing volume.
I'm saying
But
the
that's
favor
not
reaction that
important.
decreases the volume.
No, that decreases the pressure. That decreases the moles of gas, because less moles of gas will exert less pressure.
Because if it's forward,
Isn't less moles of gas less volume of gas?
No, here's a very important point. The volume of the gas is not determined by its moles. It's determined by the size of the container. So you can have a gas squashed up in a container this size, or you can have the gas in the container the room size. That
But it could
does
be the
not
same moles.
change the moles of the gas. No. Okay. So the reaction that will decrease pressure
What gas did they use for the night?
is favored.
So the forward.
And less moles of gas will collide less, so exert less pressure.
Does that mean that the forward reaction is bigger?
Yes, Tina.
Yay! Tina has it.
Here it is.
less moles gas will collide less. Less moles collides less, so less pressure. And in this case, the forward reaction is favored. Because the forward reaction makes 2 moles of ammonia for every 4 moles of hydrogen and nitrogen mix.
Yeah, no, that's what I wanted to ask. Because the side, like, okay, thanks. So because, okay, firstly, ma'am, how is this side having more moles, but then, like, that side has less? Like,
Because the old bonds are broken and the atoms are rearranged to make ammonia, and ammonia takes 1 nitrogen and 3 hydrogens.
so,
So with hydrogen and nitrogen, you need, because there are hydrogen and nitrogen are diatomic. Because the nitrogen has 2 atoms of nitrogen in it, and hydrogen also has 2. For an ammonia molecule, there must be 3 hydrogens joined to a nitrogen molecule. So here we have two atoms of nitrogen. So 2 atoms of nitrogen on the product side will need how many hydrogens? 3 hydrogen molecules. So the balanced equation takes 3 moles of hydrogen and 1 mole of nitrogen gas to make 2 moles of ammonia, because of the way that the atoms rearrange themselves to form the product.
so when you're increasing the pressure, you're not specifically increasing to the reactant side or to the...
You're increasing the pressure everywhere. Everywhere's pressure will be increased. The whole thing's pressure will be increased. But now the reaction that decreases the pressure or tends to decrease the pressure will be favored, which is the one that makes less moles gas.
Okay, thanks, ma'am. I understand and I see it and it makes sense. I'm grateful.
Oh, wait.
So this is at the old equilibrium. Increasing pressure will favor the forward reaction, am I right? So that one rises most, and the reverse reaction rises a little. Because the volume is less, the rate will increase. And then the rate of the forward reaction drops again, and gradually the rate of the reverse reaction will increase. Because more ammonia is formed, there will be the rate of the reverse reaction will increase. Concentration graph, if you had them at equilibrium, it is hydrogen and nitrogen and ammonia. So this is hydrogen, and that is nitrogen, and this is ammonia. So everything here in the concentration graph will go up. Am I right? They must all go up. Okay. But the ammonia will go up more to establish new equilibrium. And after going up, the hydrogen will drop to establish new equilibrium, and the nitrogen will drop to establish new equilibrium.
Your ammonia was the nitrogen.
Sorry.
Why is it making a
Oh,
Why is it going up in
yes, though.
Okay, so the ammonia will drop gradually and the hydrogen will go up gradually. No, I'm not. You are favoring ammonia's production.
Yeah, but you were
You were
saying the wrong
connecting the
stuff
wrong
with the wrong
dots.
things.
You were connecting the wrong dots.
Okay, so you're favoring the forward reaction,
Yes. The production
which
of
is
ammonia.
production of ammonia.
Yes.
So the concentration of the ammonia will go up
Yes.
to reach new equilibrium. The concentration of the hydrogen will go down to reach new equilibrium. And the concentration of nitrogen will go down to reach new equilibrium.
So it's the same as the temperature.
Not exactly, because not everything, the concentration story didn't work
And
this
please
way.
explain again why the ammonia increases and the other ones decrease.
Because you're favoring the forward reaction by increasing pressure.
Okay, so I'm asking, what does pressure have to do with the concentration of ammonia?
Well, increasing the pressure will increase all the concentrations of all the reactants.
Yes.
That's why the lines go up a bit.
Yes.
Okay. But the increase in pressure favors the production of ammonia. So the ammonia graph continues to go up
Favors the
gradually.
production of ammonia, so ammonia is going to be produced more. Okay, I get it now.
Yes, the concentration of the ammonia will increase.
Is it shooting up?
Everything shoots up a bit because you're decreasing the volume. And concentration is moles over volume. So if you're decreasing volume, you're automatically for a split second increasing the concentration of everything. But then new equilibrium must be established. The new equilibrium is established by favoring the forward reaction, which increases the concentration of the ammonia. It makes the production of ammonia more. And gradually it will use up the hydrogen. So the concentration of the hydrogen will decrease and the concentration of the nitrogen with the hydrogen will also decrease. A mole graph will not have the upward glitch. If you draw the mole graph, it won't have that upward glitch.
Because the moles don't change.
Yes.
I mean, they do.
I get
The moles change, but not the mole ratio.
Whatever.
No, the moles won't increase. It will just go up and down.
But it's still decreasing and increasing.
Yes. But they won't have this jump.
Yeah.
That jump is not there.
Then what is that jump? Can you please explain that?
That jump is because you decrease the volume, you increase the concentration, because they are inversely proportional. Concentration and volume is inversely proportional. So if you increase the pressure by decreasing the volume, you change the concentration. Pressure. Either by removing some reagent or by increasing the volume, pressure can be decreased, and if the reaction is written as this, 3H2 plus N2 going to NH3, which reaction will be favored? The reverse reaction will be favored. Why is the reverse reaction favored? It produces more moles of gas that will increase, yes, that will increase the pressure by colliding more often. Okay, so the reaction, the equilibrium shifts to the shifts left. What does it mean? The concentration of the hydrogen will increase and the concentration of the nitrogen will increase and the concentration of the ammonia will decrease. The rate of both reactions, forward and reverse, will do what? Decrease.
But the forward will decrease more because it's phase.
Will the forward decrease more or decrease less?
Decrease more.
Why? Why is it
No, the forward
I
action will
believe
decrease
so.
less.
why is it decreasing more?
It's decreasing less by the boy.
Body boy.
So the forward reaction and the rate of the reverse reaction is equal, decreasing the pressure. Favors which reaction?
Forward.
Favors the reverse reaction. So it will drop less, won't it? Come, we need to think now.
It also decreases the forward.
The forward one's going to decrease the most.
Oh,
I
decrease.
believe.
Forward decrease most.
I believe.
The one that is the one.
If it favors the
Reverse is favored.
reverse,
Didn't you say that if
won't the reverse decrease the most?
The reverse is favored, so we're trying to make those things.
Equals.
Yeah, so the forward will decrease the least.
That's what I'm saying. The reverse will increase the most.
Okay.
Like on the
So to re-establish the equilibrium, the nitrogen and the hydrogen must make ammonia, so that reaction must speed up. As more hydrogen and nitrogen is formed. Okay. What happens to the concentration graph here? So this is the NH3, that is the N2, this is the H2.
So it stays the same.
No, what happens to the concentration of all three the gases when the pressure is decreased? All three will go down a little bit. Then nitrogen will go up, am I right?
Yes.
And hydrogen will go up, am I right? And ammonia will go down. Right. Now, the effect of a catalyst, the catalyst does not affect the equilibrium position. It does not affect the equilibrium
The rate graph will just be steeper.
position. Meaning the following, I'm busy talking and writing, so please bear with me. It does not change in any of the concentrations of the reagents. So in our situation, there's no change in the concentration of the hydrogen, no change in the concentration of the nitrogen, and no change in the concentration of the ammonia.
So it just
No change. But it speeds up both reaction rates by the same amount. So if you look at the rate graph, if you consider the first equilibrium, then adding a catalyst will speed up both reactions in tandem.
Can you say your word again? Tandem.
It speeds up both reactions in tandem.
What's wrong with
But my tandem is my way of explaining it. If you're cycling in tandem, you are pedaling at the same rate. Both people are pedaling together. So both the forward and reverse reaction will speed up by the same amount. The concentration graphs will not change at all. So if you have the one equilibrium situation, the new equilibrium situation will not change at all. So at new equilibrium, both the concentrations all three concentrations will remain constant. So adding a catalyst will not change the concentration at equilibrium. It just makes the whole reaction going faster.
So basically this thing happens.
Yes, that thing. Right.
This wraps it up. Thank you. Have a great evening.
Good night.
guys.